So we are live. Hello, everybody, and welcome to this AI4EU in Practice Industrial Pilot Perspective session. I'm Jean-Christophe Pazaglia or Pazzalia from SAP, and I'm the main investigator of the AI4Citizen pilot. And I have with me people from Norway with Kerstin and Thiago. Then I have people from Spain with Thomas. I have some feedback, sorry. So, sorry for that, I have a very bad echo because the session was playing on background on my browser, so it was very difficult for me to continue. So I was saying we have people also from Spain with Thomas, we have people from and Juan, and from Italy with Raman from FBK, and from Greece from Athena, and we are representing the 4 pilots out of the 4 AI4Citizen for sure, since I'm involved, AI for industry, AI for agriculture, and AI for IoT. So we share my screen now. You can see nice slides we prepared for you and a nice session we prepared for you. So here you have the details of the name. The agenda will be as follows. So I will setting the scene right quickly in 10 minutes or even a bit less. Then we will have really the return of experience of 4 of the 8 pilots of AI4EU. So and you will have the grand tour of the AI4EU experimental platform by Peter. Then we have 2 scenario example by Peter and then Thiago. And you will see how we onboarded the component for AI4Citizen. Then we will continue with this return on experience with a more let's say storytelling session from Thomas that will explain exactly how they use the platform, or what was their process for the AI for agriculture session and pilot. We will have 10 minutes for that. And finally, we'll have a discussion panel where we share some of our insight of the platform, and we encourage everybody which is following the session to ask a question around the pilot. So who we are. My screen is really slow. So basically, within AI4EU, AI4EU is a 4 years project that started almost 3 years ago. A 3-year project that started almost 3 years ago, and there was a work package, the work package 6, with 8. Sorry, I'm very bad with numbers today. Work package 6 with 8 pilots, and we are representing actually 4 of the 8 pilots, because it was not possible to have everybody on board. So basically, you have the AI4Citizen that will be represented by Athena, Raman, and Juan. AI for industry that will be represented by Peter. AI for agriculture that will be represented by Thomas, and AI for IoT that will be represented by Thiago. The purpose of this, let's say, and these 8 pilots were organized in 2 waves. The wave 1 that initiate to work at the same time that the platform was developed, and the wave 2 that had the advantage that they were able to leverage already some component of the platform. The idea being that the wave 1, let's say, pilot will also have a more, let's say, more role to identify the features and to be the first player, and then they will be quickly the wave 2 will quickly join us, and will, let's say, be able to more exploit what was already existing on the platform. So the goals of this work package was to demonstrate the exploitability of the AI4EU platform for industrial application of AI. Each pilot actually have 1 industrial partners and 2 more, let's say, two partners, both from SMEs or from research, from research to support. The idea was really to try to see what we can do, how we can do it, how to foster the adoption, take into account very, let's say, more industrial capabilities that is needed to use a platform. We'll talk later, but typically something around intellectual property, privacy, and so forth. And the idea was to try to understand how we can show that the platform can be used by industrial application in order to stimulate, in fact, a partnership, the partners, not only from the research community, but also from the industry to solve AI application problems. Having different roles, using developing component, using components, developing, let's say, more generic or large-scale pilots with the platform. So this is basically what were the goals of this work package. The work package was led by Arnaud Gottlieb from Simula, and it was let's say, showing us how to best interact with the platform and so forth. So when we are talking about the platforms, actually, sometimes people are referring to the Eiffel platform. So people say platforms, and then the question is which platforms, obviously. So basically, within AI4EU, we developed one main platform, which is the Europe AI on-demand platform. And the idea here is really to be the one-stop shop that anyone from the AI community can interact. So basically, a lot of content on being, let's say, being technical, non-technical, from an ethical perspective, forums, and so forth. And the idea was really to try to drive the AI also from an EU perspective, and to, let's say, show that we can do AI which is ethical and trustworthy. So this is basically the full Europe AI on-demand platform. I'll show you later on. You have the URL if you want to browse it. And this is what I call AI for all. Part of that, there is a little spot which is called the AI4EU experiment platform, which is in fact a way for the community to share information. To share information, but not in terms of information, but really to share components that can execute, that they can assemble, and that in order to build new use case, new scenarios that can be then reused. So this is the AI4EU experiment platform, what I call AI4EU for geeks. If you look at the little URL, you will find out, for example, in AI4EU Europe, this is the news and events from a few days ago. So basically, you have a lot of different things. The good news is that if you want to connect, actually, you can use your EU login. So if you want to connect to one of the EU official websites using ECAS, you can use it. And once you connect it, you can contribute, and you can look at the different tabs. So you have something around the community, then the verticals and the industry, the research part. You have all of the education curriculum from the different partners. AI4EU was a big consortium with 80 partners, more than half of that research partners. You have and universities, so you will have a lot of different curriculum from all partners and others around Europe. Then the services, the ethics capabilities with basically the Observatory for Ethical AI. And finally, the services, which are mainly the AI4EU experimental platform, but also the possibility to have some research bundles and so forth. And finally, the last page, which is the news and events. So this is basically a very quick overview about what is within the platform. Then the second one is AI4EU for experiment. This will be indeed one of the main topic of what you will have right now, because as part of the pilot, really, the idea was to try to share, to use different components, to assemble them, and this is basically what we are doing using the AI4EU experiment platform. So that said, I will ask Peter to give you the ground tour, because he is the expert is very heavily involved in the development of the platform, on the catalog, on the education and the training material around it, and so forth. Peter?
Thank you very much. I will start sharing now. Thank you. I will talk about the AI4EU experiments platform. First, I want to say, why are we doing this? Why? Because we have formalized this as the 3U principle. We have useful assets, we have them. We want to, they are also maybe usable for us, but maybe not for everyone. So I'm a research partner in the project. Usually our software is quite difficult to set up. And what are the interfaces of that software, the data formats. And of course, we want everyone to use our assets. So the goal is to make useful assets actually usable and used. And AI4EU experiments platform is our driving force in that direction. On the AI4EU experiments platform, which is based on the Acquimos software, there is a marketplace. And the marketplace is like a collection of components. It is tagged, it can be filtered. You can see here a screenshot. The components are versioned. There is a license management for the components. And if you publish a component, it goes through a review process. And this is not the original Acquimos software, which is based on, which is mainly for machine learning. This is an extended version. We call it for some time Acquimos Plus. And this project will be moved into an Eclipse project to manage the source code, and then it will get a different name. But let's call it, we call it the AI4EU experiments platform at the moment. What is a component and what is the life cycle of a component? A component, you onboard a component, which is a Docker container. You don't upload the Docker container, you put the URI to the Docker image. And then you upload the protobuf definition, which is a protobuf source code file, which declares what is the interface of your component. And then you add some metadata. You can also add documentation, the authors, the license, and so on. But the main parts of a component that make it executable and runnable are the Docker container, URI, and the protobuf interface. We have created a specification for creating reusable components so that this platform can actually use your component. It gives specific ports for the gRPC interface, where the protobuf interface is used for communication. And you can also specify a web interface. And more details can be found in this link. I have also sent this presentation to the organizers so that it can be shared among the participants. Once you have components, yes, so back to this slide, everything, more or less everything that you need to know, you can find in GitHub AI4EU. There are various repositories, including the full source code of the whole platform that we have forked and extended. And once you have a component, what can you do with it? You can graphically assemble a so-called solution in the design studio. This, on the right side, you see a screenshot of the graphical editor. This is an example, the Sudoku example, which is a hello world example. I will give more details about this later, but the idea of this hello world is that you can use the source code, which is available on GitHub, to create your own components and your own solutions, that you have a starting point. It's a tutorial for using this AI4EU experiments platform. And you have three components. It's a user interface, a web interface. It is an evaluator component, which uses an answer set solver to evaluate if the Sudoku that you wanted to design, so that the user interface gives you the possibility to design a Sudoku grid. And then this evaluator will tell you if the Sudoku has one solution, multiple solutions, or a no solution, and gives you hints how to solve that problem with no solutions. Now, once you have assembled this solution in the graphical editor, how do you run it? How do you run it? You deploy it in Kubernetes in general. How this works, you download it. You download a zip file, a small zip file that contains all the scripts to execute to deploy the solution in Kubernetes, for example, on a local computer in Minikube or in some cloud that supports Kubernetes. And then you run the so-called orchestrator, which is automatically created or shipped with the Kubernetes solution. And this orchestrator connects the components and runs the solution. So you don't need to know how to connect these interfaces. It's done by the orchestrator, and the design studio makes sure that all the interfaces are compatible. Now, what is the solution? This is just a life cycle. The solution is assembled graphically, validated. You download the zip. This contains scripts for deployment, YAML files for the Kubernetes deployment, and the orchestrator client. You deploy it in Kubernetes and start the orchestrator client, and this connects the component. The orchestrator passes the messages between all the components. And this is a screenshot of this hello world. On the left side, you see if you click into an undefined field, you can choose the number. On the right side, you see a partial solution where the 6 that you chose in the left side is now here 6, and this is a partial solution of a few possible solutions with the 6 number here. Number 6 fixed to this field. Now, there is not so much time here to go more into detail. If you have, if you need help, if you need resources, you find them on this slide. At the moment, there are at least these two main people to ask questions about the platform. It's me and Martin Wells. There is the experiments platform itself. There is a playlist with tutorials on the experiments platform on YouTube, and the source code for the Sudoku Hello World is also online. And as a next point, as Jean-Christophe already announced, there will be now the brief tour on AI for industry. What is AI for industry, and then AI for citizen.
Thanks a lot, Peter. Thiago, are you ready to talk about actually AI for IoT?
Yes, so it's me first or Peter?
Peter.
I thought it's me first.
Oh, yeah, but you missed the AI for IoT. Then first is AI for industry. Good.
Okay.
Sorry for the confusion. What is the AI for industry pilot? It is a collaboration between 3 partners. Siemens in Germany, they do skill matching with an OWL reasoner. This means they describe the capabilities of the machines and the work pieces in a factory. And then the skill matcher produces output like which machine can produce which result on which work piece, and can also explain why certain things are not possible. Then there is TU Wien. I'm from TU Wien. We are doing production planning, asset programming. We are planning if we need this output in the factory, what are the steps that need to be done in the factory, in which order. And finally, there's Fraunhofer. And Fraunhofer uses a neural network to do time estimation. So they observe traces of the system that have been done before and learn from that to estimate how long each workpiece will be in the system before it's finished. So we can estimate the quality of the plan with that. And what are the challenges here? To make the components usable by all the partners, for that we use Docker containers. So we have no setup issues, none at all. We combine components into one working solution. For that, we were sitting together and defined protobuf interfaces. And each of us implemented these protobuf interfaces, and then it's automatically orchestrated. This worked surprisingly well. Apart from very small issues in explaining how this interface is really meant to be used, this worked very well. And the last point, protect intellectual property. So Siemens had the special case, they were not able, or they have internal restrictions, policies that forbid them to publish anything, even in binary form. And this, at least in this project with these research assets they created, they cannot publish it. So we created a dummy component for the Siemens component with the same interface. And okay, now you ask, maybe that is strange, but the nice thing is Siemens just needs to change the URI to the Docker container and point to an internal Docker repository, and suddenly Siemens can run the whole solution with their own component, and everyone else can run and test the solution with the dummy component, which is currently published. This is the solution. We have the user interface on top, where you specify what is the desired outcome of the factory. You have the skill matcher dummy, which is a dummy for exactly this kind of ontology we use here. Then we have the planner. The planner creates a plan, and the plan goes into the time prediction module, and the time prediction module passes all the information, including the plan, into the user interface. And here I show just a part of the interface. How do we specify the planning request? We say what is the desired magazine state. In this factory, we have magazines for the output where all the pieces are listed. And in the magazine, there can be a list of output products, repeated string, and each product has one color, red, white, or blue. So this is a list of colors. And the planner request consists of an ontology. This ontology is used for planning. And then for each magazine that we have, there is such a magazine state, a goal, and then how many time steps we plan in the factory. And now is the demo time. Now I hope this will work. Can you see the video? I guess.
Yes.
Okay, this is video. So this is the user interface. On the right side, you see the factory. You see there is a supply point where products enter the system, a conveyor belt. The products go in a circle here on the conveyor belt, and there are two stations that modify the product, and there are the sorting magazines. This is a real experimental factory of a sub-company of Siemens, and we have seen it. It exists. There is a video about this. You can see the video also on the YouTube playlist. It is a really cool experimental factory. And what can the stations do? So they press a cap on some base. So bases enter the system, and on each of the stations, a cap is pressed onto the base. And there are certain colors of caps here, which means the products sometimes have to go in cycles to wait for other products to use certain colors so that they can get colors. They can get the right color. Here in the user interface, we specify the goal state. We submit it to the pipeline, the number of steps. And here below, yes, and then we get the result already. And here below, we see the resulting plan and the time estimation result, which is 65.9 seconds for the first and 92.2 seconds for the second piece. And now in the video, I will modify the requested output state so that it gets an additional workpiece in the additional product in magazine 0. And the plan still has only 7 steps, but this time there is more parallel processing in the plan because there are 2 stations here that can press caps on the bases. Yes, this is the user interface. And that concludes my demo of AI for industry. Thank you very much.
Thanks a lot, Peter. So as announced before, Thiago will talk about AI for IoT.
Yeah, so thank you. Yes, I will talk, I'm Thiago Veiga. I will present the use case of deployment in the experiments platform from the IoT pilot. So the IoT pilot has 3 partners. It's Telenor, which is a Norwegian telecommunications company. So with an interest on data collection, provision, and posterior analysis. And NTNU, which I belong to. So it's a university also in Norway, and also with a focus on the data analysis. And the ET-CERT is a research institute in Greece with a focus on data visualizations and decision-making support tools. So the general goal of this pilot is to explore the use of artificial intelligence on data captured by air quality IoT devices in order to improve the data collection and the quality of the collected data. Work on real-time visualizations and on forecasting, prediction, and decision support methods from the data collected. So the global overview of the pilot looks as in the figure. So there is a network of air quality low-cost sensors deployed in the city of Trondheim here in Norway. So there's a need for collecting data and providing the data to middle services, which work on top of it. So there's a need for data cleaning, also data imputation, and especially on the data calibration from the sensors, such that the data then can be used in other services like forecasting or either with prediction or classification of the air quality levels. And then provide visualizations of the data that can be used in end services like mobile apps or dashboards oriented towards end users to help them with the decision-making process, either like general citizens or local municipalities, for instance. So here I will focus on the highlighted part. On the data calibration pipeline, as I mentioned, is a crucial first step towards making data available for the rest of the services. And in our case, we calibrate the data with the data-driven models. So basically, we train machine learning models to output the calibrated values of the sensors. And yeah, so the deployment through the experiments platform looks like this. So this is a screenshot of the visual editor of the experiments platform. So we break this pipeline in 3 modules. So the first one is a data source, which collects data from external APIs and aggregates. So in our case, we have access to air quality data from the sensor network. We have access to weather data and also traffic data. So this data source module collects and aggregates this data and passes the data onto the calibration module that includes a pre-trained machine learning model. So this outputs the calibrated values for the data coming from the sensors, and then is passed onto a visualization model that exposes a web interface. And then can be used by these end services that I also mentioned, the apps or the dashboards, etc. A few characteristics that I'd like to share about this pipeline and our implementation through and deployment through the experiments platform that might be interesting to share for the audience. So the first one is that APIs we use to collect data, some of them need private credentials to access the data. So we cannot include these credentials with the containers. So these credentials are given locally at runtime by a user running the pipeline. So it's passed onto the container locally. Also, as we get as new data incomes, so we can, for instance, update our calibration model with the new data, or we can work on better visualizations, for instance. And with the deployment through the Kubernetes environment, it's possible to update one of a single container without actually needing to stop the whole cluster. So this makes it efficient to do specific updates on the pipeline without breaking the whole flow. And also, in our case, the income data is updated every hour. In our case, so there was a requirement for run the pipeline and update the calibrated values also in a regular basis. And as an example, this is how the interface with the calibration module works. So as input messages, we have weather data and the raw data from the IoT devices. And then as the output, the calibrated values outputted by the machine learning model. And to finalize, I would also like to show a small demo. I'll try to maximize the video. And hope that it runs. Okay. Okay, sorry for that. I'll just show it like this. Yeah, so it's just a web interface. In our case, we have we have calibrated 2 sensors in the network. It's ongoing work to calibrate the rest of the network. And this interface is just a simple visualization of the historical data for the past 12 hours, where we show the raw data and also the calibrated for each of the sensors. And I think I have already passed my time, Jean-Christophe, so maybe you'll take it from here, and yeah, I'll open to any questions that might arise as well.
Okay, I think yeah, we'll take the question after. Maybe the time for my colleagues from AI4Citizen to show how they use the platform to deploy the component that we develop during AI4Citizen.
Okay, Jean-Christophe. Let me share my screen. One second. Oops. Okay, the AI4Citizen platform is a joint effort between SAP, which is basically Jean-Christophe here, and then FBK, Raman, Ornella, and the Spanish Research Council, the Artificial Intelligence Research Institute, which is Athena, Lucia, and Juan Antonio Rodriguez. Okay, so the AI4Citizen pilot addresses the problem of supporting the providing decision support for the schoolwork alternation program in Italy, in which around 1.5 million of the students with the ages between 15 and 18 take part in this program, where they alternate school and work during 3 years. So it's like they alternate so that they spend like between 200 and 400 hours in industry. The idea is that they enrich their training and they consolidate the acquired knowledge in industry, and at the same time they work in industry, they develop their competencies, and then they learned how to choose their future career path. So basically, this is the process that we want to support, because this is something that is mainly manually carried out nowadays, and is a very costly process. So basically, the problem here is that what we find is that on the industrial side, industries just publish the internships, available internships. These internship programs require competencies from students. And then on the other side, we go on the school side, students acquire competencies. And these competences, okay, so that are those that are put in practice when the students go and work in industry. So there's a matching problem here. So the way nowadays works is that these internships are just expected to be covered by a single student each. That's the way it's handled. So what we design in the AI4 Citizen pilot is something different. We consider that nowadays active learning considers mostly collaborative learning. So instead of just thinking of sending individuals, students to internships, we thought about supporting just the sending of teams of students to internships in industry. So the problem here is, okay, we've got these pool of students that must be sent to different internships. But how? The problem is, how do we do that? We do that, we do that taking into account several things. We got to take into account the competencies we offered by students and required by industry. The personalities of the students, because it's well known that in teamwork, not all personalities get together well. So we got to put together teams that in the end work well together. The preferences of the internship, that's something very important, is that students, of course, have preferences over the internship they like to take. And then there's something called the social cohesion, which are the preferences between students themselves. So in order to implement the AI4 Citizen, we just developed three main components. One of them is a chatbot using SAP technology. We won't get into the details during this presentation about that one. But then we developed a second component that Roman will be presenting right now, which is a component that is able to mine, just to extract competencies from free text. And then the other main component is the component that just takes the students and partitions them and allocates them to internships. So now Roman will start describing the AI4EU competencies component.
Thank you, Juan. So the goal here in this specific component was to solve a very concrete problem. So on the one side, we have companies that offer these internship opportunities and provide a textual description of what is going to these students are going to have to perform, to do during the internship, or which kind of competences they are expected to have. And on the other side, there is a school that plans these activities, what the students have to acquire, as well as the experiences of the students, curricular and extracurricular experiences acquired before in order to perform some kind of MASH. So nowadays, the MASH is happening manually, so quite a complex management systems. And working on this management system, we understood very soon that there is a need to bring this to bridge this gap between the descriptions. And given this, the fact that the competencies are provided, these informations are provided in free text without any reference to a standard common language, the first thing was to understand what would be this common language and how we can translate this information into this common language. So given the fact that we are speaking about the work activities, so the industrial activities that the high school students are expected to take part of, the thing that came immediately to our mind was the ISCO taxonomy. So this taxonomy of competencies, skills, qualifications, and occupations that is defined by European Communion and community and has more than 13,000 definitions, multilingual in 27 languages. It is hierarchical. It is very well structured for the description of these kind of activities. And our approach was to make both parts speak this language. So to translate the textual descriptions and activities and experiences acquired by the students, as well as the plans, into this ISCO taxonomy. In order to do this, can you please go on the next slide?
Yeah.
Thank you. Well, we implemented an algorithm based on the NLP techniques using Facebook fast text library, which is actually open source library supporting more than 100 languages that allows to basically to compile in a quite an efficient way semantic similarity between the free text and well, between the two texts, and we use these to make the map matching between the descriptions provided by the companies or schools and the ISCO competence descriptions. So we have pre-computed the ESCO models in order to make the extraction faster. We realized that this is an algorithm as a component that actually has a very simple interface. So it takes REST API, basically, that given a text and some weights in order to calibrate better the extraction algorithm, to provide a list of competencies ranked according to the similarity measure. So given this component with a very basic interface, we decided to also onboard it onto the platform and make it available as a component that can be reused also in other contexts, since the by itself, this tool does not contain any specific scenario-specific information, but it may be suitable for other scenarios. So, next slide, please. The onboarding process we followed has already been presented by Peter, and let me also thank him for a very comprehensive and explanatory information provided on the GitHub of the project, and also on the this Sudoku scenario, following which we have implemented the onboarding process. So following the preparation, following this process, what actually happens is that we had to make some preparation, as it happens actually to any component that has to be onboarded to the platform. Well, to convert the implementation to the protobuf API to protobuf server sort of implementation, and create a corresponding Docker configuration and image file that has to be uploaded to the to some Docker repository so that it becomes available to the to the framework, to the platform. It is very straightforward in our experience. So we have implemented a similar way that we have been presented before, the protobuf and the implementation following the suggested template, let's say, for using Python libraries. And well, it's not very difficult to convert it to some other languages if someone doesn't use Python, since the implementation is really straightforward. We didn't have problem with our own repository, since we used Docker Hub for this purpose, and the wording was quite simple for us to carry out. So whenever this comes to standard repository, this is very simple. Next slide, please. Well, the onboarding steps themselves are quite simple as well. So what is needed once you have all this information prepared is basically to create and publish metadata, which comes to defining some metadata information, protobuf file, the reference to the repository, and provide some other information in order to publish it on the platform, so that it becomes available with comprehensive descriptions and information about the authors into the marketplace. So once these steps are happening, and this is driven through the user interface, which by itself, in our experience, was very explanatory and simple to use, given also the supporting tutorial videos and explanations. In some steps, we have been we faced some minor problems. For instance, there was interface blocked in the awaiting approval phase, but successfully published afterwards. So we used all these steps. We didn't test the deployment process, which is also available from the platform. However, what we have seen is that the artifacts that can be downloaded and executed are contain all the necessary information about the deployment to Kubernetes, about the images to be triggered, and the necessary descriptions how to carry this out. So this is what you can see on the public catalog, and this is one of the components that can be experimented and used without any particular restrictions. It's published under open source licensing. And this is the process of onboarding, where you once on board, you can do the publishing process, provided all the necessary information. So basically, provided the publishing authors, the descriptions, the license information, and additional documentation if needed. This was our experience. Thank you.
Then in the as I mentioned before, in the AI for Citizen pilot, we pipelined 3 components: the chatbot, and then the component just described by Raman, and then after that, thanks to the competencies just extracted by the competencies model, then we could use we had to develop a novel allocation algorithm to just partition students into teams and allocate them to internships. That was a novel development, but the thing to mention here is that this is not a machine learning component, as the component is described by Raman. So this is an optimization algorithm what we developed here. So this is a new component called the edu2com that you can see also here in the platform. And then I think that Athena is going to take chances and is demo time. And I think that she wants to do a live demo.
Yeah. Okay. So I guess you see my screen. So I will start by the protobuf, what we had to do. As Juan mentioned before, we have some main components, such as the agents that will represent the students in this very specific pilot, the tasks that correspond to internship programs, and then we have the different types of preferences regarding the projects and the other agents as team members. So in our example here, we will use a very, very dummy example with 6 dummy agents to represent the students, 2 dummy tasks to represent the internship programs. Both agents and tasks uses the ESCO competencies that have been extracted from the previous component. And we also have described the agents with their personality and their gender. In this particular example, we also use preferences of agents toward the projects, which, however, it is optional. You may not use it if you like, but here we use it. So we have already run our example, and what we see is that the result of this process will give us an allocation of which agents should be allocated to its task, along with the set of agents that are unassigned from the process. So as Juan mentioned, actually our components, sorry for that, can be found here in the AI4EU platform and under the name edu2com. It can be downloaded and be run locally or with Kubernetes. So that's from our side.
Okay, thanks a lot, Fasina. You want to conclude? Juan, or it's okay?
Yeah, one thing that I'd like to mention that I think is also interesting, probably Roman has something to say here for the discussion, is that in this pilot, we just found as well that there was legacy software. So there was some software, because actually there's a system being used to support this schoolwork alternation program. So we developed these 3 components to support a new way of doing this schoolwork alternation program, but there's legacy software there. So there's a mix of, we mixed machine learning technologies with all the non-machine learning technologies, plus we had some legacy software there. So that's very particular in our pilot.
Thanks a lot, Juan. So we'll then move, let's say, to the session panel, but to conclude, let's say, the return on experiment, I think the story from Thomas on the AI for agriculture is quite interesting. So Thomas is a totally different field than what you have seen so far. We'll talk about wine and vineyard, and also he arrived, let's say the AI for agriculture arrived later or pilot, so he had the chance to be one of the first to be able to use a nice version, an improved version of the platform. Thomas?
Thank you, Jean-Christophe, for introduction. Yeah, this is a pilot, as Jean-Christophe was mentioning, that took part in the second half of the project. So basically, we are finalizing it as we speak. So the idea of this pilot, let me go to the first slide, is that as you can imagine, precision agriculture is quite an interesting field, also called smart farming or precision farming in some cases, that aims at analyzing data from the agricultural domain to be able to predict or improve and optimize finally the production and quality of the farming processes in general and the products, and also trying to reduce the environmental footprint, of course. So in this scope, what we tried in this particular pilot is trying to understand how this AI4EU platform and the application of some AI techniques to help farmers in particular to improve their products in our particular case, as Jean-Christophe mentioned, related to vineyards and the production of wine, from the point of view of understanding how we can help them in order to do some decision making based on the different prediction models, especially for the yield or for the harvesting of the grapes in the field, and also for the quality. So it's a specific application. We are not targeting the whole scenario. Let's say for precision agriculture, there are many other scenarios that can be tackled, but this one in particular. So the assessing the quality and the production of different vineyards. So for that, we use different components. We develop some models, and finally, the aim of course of this specific pilot was to somehow showcase the results in the AI for Europe portal. So let me go to the next slide. So in principle, the pilot has been trained and validated with data from the Ribera del Duero region in Spain, which is a well-known denomination of origin region in Spain, with 3 vineyards. It's important to also understand that these 3 vineyards were not part of the project. So we engage them, especially our partner, Smart Rural, who is here also in the slide. It's an SME that is dealing with customers in the wine and when the wine production, and through them we reach 3 vineyards, different vineyards that produce wine, and they decided to help us in the process of somehow participation of this proof of concept and application in a specific land parcel that they gently allow us to use within the pilot. So we've flown drones and also took pictures in the ground with mobile applications during the summers 2020 and 2021, which was challenging due to the COVID situation, especially in 2020. But nevertheless, we decided to go and take data from the field, especially the drone data and also mobile data from this mobile application. And also these 3 vineyards allows us to use their parcels, the parcels that they provided to us in order to get the information and to harvest during 2020 and 2021 in these specific parcels to somehow knowing get training data and also validating the results. So we got training data for future research, which is quite interesting. It's not only the models that we develop, but also the existing data set that we would like to publish as well. So this is an important aspect. So regarding the involvement of the different partners, as I mentioned, Smart Rural, which is an SME based on Spain, They develop they are developing for their customers an intelligent solution for farmers, and they led somehow the requirements of the pilot, but also the data collection, because they have drones, they have the mobile application that they use for data annotation, especially the images from the mobile on the ground. And yeah, through them, as I mentioned, we reach these three binders. In our case, we have more partners than in other pilots. Atos is working as a task leader, and also from technical perspective, developed the final yield and quality models, as well as helping in the integration on the platform of the different models and data. While we have in academic partners such as DLR, the German Aerospatial Institute, who is this partner is quite have a lot of expertise on satellite data handling, especially in this particular project. They develop a model to correct the NDVI, which is the vegetation index based on the data from the Sentinel-2 data from the satellites, but also the drones. We have also the University Polytechnic of Catalonia that they have expertise on computer vision, and they developed the computer vision model related to fruit counting, so counting grapes on the field, as well as led the process of labeling the data for training purposes afterwards, and also dealing with a methodology to provide this labeling for future research as well. And last but not least, we have the University of Athens that provided expertise, especially in data modeling related to knowledge graphs. So all the data that we collected and also the results from the model end up in a knowledge graph that provides an unique point in order to access the data, access the results of the model, and access all the data that we can get from not only from the field but also from the binders. So we don't have only computer vision models, but we have also weather data or other type of data that are stored in our knowledge base. So the pilot started, as I mentioned, in the second half of the project, even though we started in summer 2020 to get this data. And the thing here is that these models work in an asynchronous way, in the sense that it is not easy to create pipelines because we take pictures in different periods of time. Not always after taking the pictures we need to run the models, but we need to clean things. There are many aspects that make it difficult to create pipelines. So what we did is basically publish the models and use the models in a specific application, as you will see later. You can see at the bottom that we deliver some of the models into the two catalogs that we have in AI4EU. The AI experiments catalog, which is the Acumos Plus that Peter was mentioning before. So the models available for running on Docker containers with the protobuf interfaces and so on. And we also provide some extra data and information about the models into the AI catalog. So it's important to understand that not only models are the result of this particular pilot. Okay, let me go to the next slide quickly. This is the architecture of the pilot. I'm not going into the details, but let me just briefly explain that we got data, as I mentioned, from drones, from pictures from a specific application developed by our partner Smart Rural. We get also information from the binders, lab data, weather data, etc., etc. All these end up into the knowledge graph that is depicted at the top of the figure. And then we have several models running on top of this data and the images. So what we basically, as I mentioned, the first model is the counting model. So you can see a screenshot from the model in the platform, and these counting models, based on computer vision, detects the areas of the images that are covered by grapes. These areas later on have to be somehow updated based on the vegetation index, because sometimes the grapes are hidden by by leaves if there are a lot of vegetation in there. So this is something that we do behind the scenes with the combination of the two models, the NDVI and the counting model. Once we have these two models run, what we do is using this all this information, the data that we have, the annotations from previous campaigns, in order to run a model that detects several indicators related to yield and quality prediction. So we have developed a model that allows to specify the specific field that we would like to calculate. If I would show you it later in an image, the ones that are more important, and then the model can run and we store the information into the knowledge graph. And this is made available via Spark Web queries to the final point here, which is the user interface of the application. And we prepare a couple of different user interface, one using some tools available in the platform, such as, for instance, Strabon from the University of Athens, that generates specific maps with the data that we develop using Spark Web queries on top of the knowledge graph. But also we develop some specific user interface into the smart rural application that they use for their customers. So we plan not to create let's say production grade application, but at least to show that this could be done based on the results of the project. So basically, yeah, the conclusion now on our side is that we use the platform as an end-to-end proof of concept of the entire application, especially because we needed a lot of teamwork support here, because it's not only develop a single model, but we need to be synchronized and try to understand each other, and also using standard ways of deploying our models. As Peter was explaining before, using Docker containers, protograph wrappers, etc., etc. So this helped a lot in order to have a common understanding on how to deploy these things. The actual deployment took place into the smart rural site. They use a Kubernetes cluster, small Kubernetes cluster with the resulting models, and we run the models there, except the knowledge graph that ran into the premises of our partners, University of Athens. But for the rest, everything runs into the smart rural servers in Kubernetes. We also did some nice application showcases of the platform very quickly. I don't know if I have at the time, but just for you to show a live result. So this is the result, for instance, of a specific vineyard. With in red you have the specific land parcel that we were using for getting the data, for predicting the values of quality and yield. So you can see that we have several visualizations. We have different values for the prediction model and the actual result of in the field. So in order to validate the result, that were in principle quite good. Although we know that the more data we have, the better the models will run as usual. So we know that we need to improve the models in the future. This is something to work with our partners, and then maybe this proof of concept could go to a actual production environment. But so far, you can see this can be depicted. We have different visualization schemas. We have a selection, for instance, of different land parcels. We use up to, I think, 15 land parcels in the three vineyards. I'm selecting now a different one. The user interface could position the map into the place where the vineyards are located. I took probably too much because I think I selected everyone. So let me select just the first three of them, just to, if my laptop allows me to do so, because yeah. Okay, so as you can see here, the map has positioned into the specific land parcel, and you can see the different visualizations based on the data that we retrieve, with information about potential alcohol of the grapes, total acidity, pH, and other interesting indicators of quality and also of yield that can be shown in a graphical user interface using the behind the scenes this knowledge graph and the overall set of elements that we developed within the pilot. And I think that's all from my side, Jean-Christophe.
Thanks a lot. I think it was quite impressive what you managed to do with the data that you have and so forth. So maybe to start the question, because you're on stage, this virtual stage, obviously, what was the real added value that you find out, especially with the community of actors that you have around your table on your pilots?
I would say that there are several takeaways from the pilot. One interesting fact is the one that I already highlighted about the collaboration, because we are different organizations working together towards a specific pilot that is dealing with completely different things, different models, different ways of acting, different deployments. And we found that it's quite easy, with the problems, there's typical problems, but it's quite easy from a technical perspective to actually develop an application based on the framework, so the AI4EU experiments. Especially if you follow these de facto standards such as protobuf or gRPC, and these type of things are quite shared among the community, especially the developers, and this makes quite easy to understand each other in a sense. Then there are parts that are not so easy to understand, especially because, as you know, the project is ending now, but still there are some things going on. As usual in these big projects, one thing is what we expect at the beginning, and another thing is how we end up having the platform. So in general, I would say that the experience was quite instructive, and in this sense, I think it's interesting to see how different partners could work together and prepare a kind of production grade in the end application that could be deployed in different scenarios and different partners. So this part, I think, it was quite interesting. And also the possibility of sharing data, for instance, data set, labels, this type of things are also a result of the project. And I think that would be quite interesting for researchers in the future.
Okay, thank you. I think on the same vein, I do have a question to Thiago, because while Thomas, correct me if I'm wrong, you're mainly using, let's say, data that you collect and then you do the processing. Thiago, you're using real-time data and so forth, and I expect that you want to be able to deploy the same type of use case on different cities. How can you do that with the platform?
Yeah, I think it's one of the interesting points in the platform, because, well, we have this this pipeline we created in most of the features is a general pipeline, which can be replicated, I would say, anywhere in the world which aims to build a similar structure. There's a few things that with an update on the platform will make it even easier. So I'm thinking, for instance, because we need to pre-train our model, and then we include in the calibration container, so we include the pre-trained machine learning model, right? But to make it even more reproducible, it would be good to have training functionality with the pipeline. So basically that anyone can train with their own data. And as long as I know is predicted for future versions of the platform, or it's still on the predicted functionalities. So with this, I think that the platform, and because of course our solutions and components are made available in the marketplace of the experiments platform, so anyone can access it and anyone can reproduce the structure we have built.
Okay, great. Okay, Okay, your last sentence actually, everyone can reproduce it and so forth. I have a background in security for the people that know me. And I was quite, let's say, interested to learn a bit more about what you already described, Peter, about the intellectual property, because Siemens, one of our partners from SAP, they have this kind of pre-trained model that we do have, and how can you use them without disclosing your model?
So there are several ways that you can protect your model. You can publish the URI to a Docker image where the Docker repository is password protected. This is possible. Then only if you have the login credentials to that Docker repository, you can use that component. I mean, you can put the component into the solution, you can try to deploy it, and only if your Kubernetes setup knows the key to that Docker repository, you can actually use it. That is so because you never upload, you only upload the image to the platform. You don't upload the asset. The asset lives in some Docker repository, and you can create your own Docker repository, like Nexus. You can run your own Nexus that is password protected, or you publish a component that is a dummy component, and then everyone who has access to a repository with the real component can just change the URI in the Kubernetes deployment files and runs the right component. So the protection is by not publishing it. Actually, there is no encryption or keys or anything. The protection is by the access to the Docker images.
So basically, you create something which is empty that you use to compose the solution, and then at deploy time you substitute by the real component.
You have to specify the interface. That you have to disclose.
The only thing that you disclose is the interface. Okay,
yes.
Great. Makes sense. So the next point when you're talking about security IP protection is also about privacy. And this is something that since I think when we engineer AI for citizens, also always, let's say, worrying about, let's say, the privacy, especially we are talking about young adults. So Raman, can you tell us a bit what did happen?
Yeah, one of the key issues in that project was also to protect the personal data, given that we are speaking about the high school students that are not even created, so they are their data is considered to be sensible in this sense. So this means that this following all the directives, it means to design the security and privacy from the very beginning and be very careful about this. What we have done is to not to pass any sensible information wherever it is not needed. So all our data was anonymized so that you can, the students, even interacting with the chatbot, obtain upon the authentication, they obtain only or store only some information about themselves without any reference to personal data. So their preferences cannot deduce some, let's say, facts about them or give some hints about who these persons are. And through all the components that are then engaged in decision, this information is not passed. So we only pass the anonymized identities of users and some generic information about, for instance, the internships they are interested in, or the competences that are not personal in any way, since they are extracted from the standard taxonomy. So this was the way for us to not allow any personal data flow into the system or make any harm.
Okay, thanks a lot, Haman. Since we are talking about passing the interface and so forth, so it's about interface. So it's already twice it happened on the protection and so forth. So when we're talking about the type of interfaces that you should be defined by a new component, can you be a bit more, let's say, precise about, let's say, the amount of time that it takes, Juan and Athena, when you did, let's say, the component, and you publish the component, how long does this take to take, let's say, your component to a component that can be deployed in the AI4EU experiment platform?
We had to build the prototypes, as it is already said, and specifically in our case, we had to wrap it around an already existing system. So it was apart from the prototypes, we also had to build some parsers to encode the input and output in the correct format. So in our case, simply because we didn't have a lot of knowledge over the prototypes system, it took us around a day to build all this interface. But it's very simple and very easy since someone is aware of how to do it. So it's basically very simple. And on the onboarding, it's straightforward. The tutorials that exist are very clear and very easy to follow, so it's not something very difficult.
Okay. So I think maybe something like that. I will go. I think when we are talking, because we are talking about different type of component, and I was just people I've seen during the different presentation. We are talking about very different type of components. So we are talking about, in the last case, it's kind of a constraint solver for the constraint to build the right, or one of the best assignment from students to teams. They were talking about ontologies, matching. Thomas was talking about conceptual graph and so forth. So I think one thing that people should be aware is that really the platform is not only about machine learning, even if machine learning obviously is very high nowadays, and that you need to do specific thing for machine learning. So maybe one question dedicated to machine learning, but please take into account that it's not only about machine learning on AI4EU, as you have seen. Peter, when we're talking about training and evaluation of machine learning models, how does that work?
There are several possibilities for that. So you can pass the models between the components using protobuf, or you can use a feature that we added to Acomos. You can use the so-called shared folder feature, which will create a volume, a persistent volume in Kubernetes that is shared as a folder in all the models that are connected. And then you can train a model on this shared folder, and other components can use it, so that you don't need to pass the model among all the components. This is those are the two possibilities. Of course, you can also ship your model with your component, but this is a bit less flexible. And in the future, we plan to have model initialization. This is again a virtual node that is a component that is not a real running component, but it is more or less an initializer for another component. There you could also pass a model to another component.
Okay, great. I think just checking a bit, there was nobody asking a question from the people following, and we know that some people were following. So I will ask yet another round of questions to our panelists, but feel free to ask a last minute session, so you get the chance to get the insight. I think you have with all of the people around, you have people that really used for real the platform, or even develop the platform or develop components. So you should get the chance to ask the question. So the next question will be about, let's say, and it's about if you want to be in this role, about the engagement and the roadmap, is that what is a bit the process that you have to follow to contribute to component and so forth? We have seen some nice screens, so some nice screen, but maybe you can say a bit more about the insight, and also do you get the support for that, not only from Peter, but also maybe from the committee in the near future. So I don't know, Atina, Raman, or others, what is your opinion about that?
Well, the way the tool is structured, so the marketplace and the environment itself is structured, makes it quite easy, for at least from the perspective of technical people, to do the contribution. Well, we are used to work with the templates, with the code, with the with information on how to, starting from the code, to do something concrete. Okay, so given a very nice tutorials, and in this sense, I believe the video tutorials as well as starters like repositories provided within the project help a lot. And for technical people, this may be of help. And in my case, it was even so straightforward, so I didn't ask for any support in order to do the onboarding process, and the interface was quite straightforward. Again, this is a perspective of technical person. So how this is, how simple it is for people that are less technical, I don't know, but probably the less technical people will not go and do the experimental component provisioning. So some technical, some certain level of expertise, of course, is needed in order to do this operation. But probably what would also help is the presence of templates for different frameworks and different languages. So for Python, it's which is actually the reference language for AI, it's without any doubt. But for other languages, if we could have some templates provided by the community itself, would also help. So this is something that we can think about.
Thanks, Roland. Maybe something I wanted to add, because I didn't. I was just thinking about that while you were speaking. Is that okay? We are on the stage one, which is about trustworthy AI, and we didn't really talk about trustworthy AI, except that we did talk indeed about IP protection, privacy protection, and so forth. But one thing that people should be aware also when you onboard a component part of the process, there was something about the process. In fact, there is a set of questions that you have to answer that basically give a kind of, let's say, feeling about how trustworthy is your component, and in terms of intention, about the data manipulation and so forth, about the openness of your component. And this is something which is part, in fact, of the process when you develop a component, not to develop the component, but you want to publish the component. In our case, it was, okay, we did it beforehand, so it was quite straightforward, but you have, let's say, 20 questions and to answer to become public, but there are basically questions that you should ask yourself when you want to deploy something that should be used and potentially may harm people. This was something I wanted to add. Maybe to understand what is the next stage. And once again, Peter, because Peter is involved in the development stage. What is the next stage? Where, okay, what will happen to the platform?
So thank you for the question. As I mentioned, we will move to Eclipse Foundation, the Eclipse Foundation as a process to manage the software that we developed. So we used the Acomos software and we extended it, and this extended software will become a project under the Eclipse Foundation for the governance processes and the release process and the feature request process. So whoever wants to add features, has feature requests, finds bugs, can do this publicly in interaction with this future Eclipse project. Future means I don't exactly know when, but the onboarding is ongoing. So it is already approved that it becomes an Eclipse project. It's a matter of weeks, I think. Okay. And so at the moment, we have everything on GitHub, on the AI4EU repository. So at the moment, you can interact there with issues. Does this answer your question?
Okay. Okay, and so that's basically, and when the, because we have all of the community also about the ICT48 project interacting with us or using the platform.
They are interacting, and they will be part of continuing the development on the platform. So we have several points, things in the pipeline that we want to improve in the platform. Some things have to do with user interface to make it more responsive, to make it simpler, something to make the deployment simpler. And then there are features that are real features. What can be a solution? How can a solution look like? How can the messages, the message types between the components maybe be converted automatically to become more flexible? This is more long-term, these improvements.
Thanks a lot.
In
Thomas?
fact, Jean-Christophe, if I can step in for a moment,
Yeah, sure.
because we are working, some of us also in ICT 49 projects, and
Nice.
I think it's a good opportunity also to engage with all these projects and find a way to make the AI4EU platform, the AI on-demand platform, sustainable, not only from a technical perspective, but also from many other perspectives. So I think that we have enough results in the project to be proud of in a sense, but also we need to improve a lot in some others. So I think this is a very important step, having this set of projects that are working with the AI4EU platform, and also working with industrial partners. I think it's important to, at the end of the day, to hear what industrial partners have to say, because if not, the platform will be restricted or mostly working for academic partners. And I think the idea here is to have the industrial perspective also quite relevant. So it's important that in the future, with the new projects that will be working in the platform, we engage all the industry and being able to have something that is valuable not only from the research perspective, but also from the industrial perspective.
Yeah. Makes sense, I think. And as you said, in fact, let's say, better will be the catalog, better will be the platform too. More asset you get on that, and more reuse you can do, or you can compare what you do with what was done, and then also benchmark yourself against others. So maybe we have let's say 2 or 3 minutes remaining. Maybe just a round table about what is the best feature, your favorite feature of the platform. I think maybe Juan, because you didn't interact since you talked. Maybe what would be your favorite feature? And then we go to Thiago, for example.
Well, to me, what was surprising was the very easy embedding of a Docker. I was very surprised. I think I mentioned before, I was terrified thinking about how to onboard what we did, and to be honest, it was very, very fast. It was very simple to do. That's the thing I really liked.
Okay.
If I may, I just have to acknowledge that we had a very good support from Peter. It was very fast, and everything was answered right away. So thank you very much, Peter.
It was very, very swift. It was, in fact, we had arranged to meet with Peter to help us to do the onboarding, and it wasn't necessary, because first Raman did it very quickly, and then we did it very quickly, and then there was no need for a meeting. And then even if we had some things with our Docker, because we needed a private Docker, there's even the possibility of having the platform's Docker repository. So everything was very smooth.
Okay.
So thanks, Peter.
Thiago, before Peter will eat his pizza.
Okay, yeah, quickly, I'll just mention the automatic orchestration. So I think it's very useful, and that the platform gives you all the configuration to deploy in the Kubernetes environment. So it makes it really easy. In the personal note, I had no experience with Kubernetes, Docker so far. And well, I thought it really helped on being able to deploy the pipeline in this environment.
Okay, Peter, the final word for you. What you like about the platform.
My favorite feature is actually a very technical feature. It's the message streaming, which allows that one component sends not one message to another component, but a stream of messages. It's the stream keyword in gRPC, and it was not implemented. And it's also my favorite feature because I implemented it. And now you can combine components that create events like user interfaces, events of various frequency whenever the user clicks, and then this can trigger computations in the rest of the solution. And this allows so many things. It allows to have cycles, control circuits in solutions. It makes the whole thing, the whole orchestration much more powerful. And interestingly, the orchestration also became much simpler through that, because each remote procedure call is just a thread, and that's it. So that's why I like this feature a lot.
Okay, perfect. I think we are at the end of the time. Thanks for everybody. I hope that the people still connected like let's say the spectrum of different pilots, the different types of components, and the insight that we gave about them. And thanks for everybody that support me in preparing this session. And see you in Ljubljana tomorrow. That's it. On stage. Bye-bye.
Bye-bye.
Bye, everyone.
Thank you.